Today we're sketching derivative functions, and we're sketching it from the original graph, not the function itself. So let's look on the left here. At the top, I have my original function, and on the bottom, I'm going to sketch the derivative. The first step is to always look at where there is a zero gradient. Now, can you see where the zero gradient? It's at the turning point. So let's draw a dotted line down because that's exactly the same x value that I'm going to have a gradient value of 0. It gives me the x-intercept. So once I've put in all the x-intercepts for the gradient function, i.e. everywhere there's a 0 gradient, now I look on the left side of that 0 gradient and on the right side of that 0 gradient, and I look at the gradient value. So I can see this is a positive gradient value. So I'm going to have positive gradient value on the left and upper side of my 0 gradient. And now let's look over here. This is a negative gradient value. So our y value of our gradient will be negative, but that's only to the right of my 0 gradient. And if I join the dots or join the areas, I get a line. Now this makes sense because this original function looks like an x squared, a parabola, and if we take the derivative of that, we do get a line. Okay, let's move on. So, as always, we start with the 0 gradients, and I can see at x equals 0, I've got a 0 gradient. So I'm going to put in my intercept there. So looking on the left of the 0 gradient, we have a negative gradient. So I'm going to have my graph somewhere in the negative region. And on the right side, I also have a negative gradient. So joining up those two regions and the 0 gradient, I can see that's the only way I can join them. This makes sense because this looks like a cubic, and when you take the derivative, you get a quadratic. Let's go on to the next one. Now this also looks like a cubic, so I'll probably get a quadratic, but how will it be sitting on the graph? That's the question. We have two 0 gradients here. So there's going to be two x-intercepts on my gradient graph. And now let's look at the left side of that 0 gradient. It is a negative gradient. Let's look in the middle between the two 0 gradients. It's a positive gradient. And on the far right, it's again a negative. So joining those kind of dots, I've got something that looks like that. And that's sort of what we expected, a quadratic. Let's do some different looking ones. Okay, always start with the 0 gradients. So we've got one there, let's bring it down. Now, things are a little bit different with this. So we're going to have to not just look on the left and on the right, but we're going to look at on the left close to the 0 gradient and on the left far away from the 0 gradient. Let's start with far away. Now that to me looks like a very close to 0 but positive gradient. So very close to 0 but positive. And then let's move up to getting close to the turning point there. It's a positive, but it's getting much more steep. And then it flattens out. So can you see it's flat, it's steep, and then it's flat. So let's maybe look at the steepest point, and let's draw a dotted line down here. It's going to have a maximum gradient probably there, and then go back down to 0. And then over here we've got all of that is negative, and it just keeps going like that. I could just tidy up this curve like this, and that's probably going to be an asymptote there. Okay, this looks pretty much like a cubic, so that's going to be really similar to these ones we did above. So let's move on to I. always start with the zero gradients, but there are no zero gradients. So we're going to have to just look at the different regions. We've got on the far left, close to zero, and on the far right, as x goes to infinity. So on the far left, we've got a really steep positive gradient, and it's going to be asymptotic behaviour. So I'm going to put a dotted line there, asymptotic. And then on the far right, it is flattening out to zero. Maybe it goes to zero, maybe it just keeps increasing, but it's going to be like that. Probably is going to maybe have an asymptote there, because while this is still always positive, it's always increasing, but we can't have this gradient going into the negative. This gradient up here is always going to be positive. So we have to have our gradient function always being in the positive. Okay, we've got a quartic here. And let's drop down 3, 0. Oh, 3, 0 gradients there. And we've got 1, 2, 3, 4 regions to consider. So on the far left, we've got a negative gradient. Here in the second section, positive, third section, negative, and last section on the far right, positive. So our zeros and then joining the dots. And yep, that makes sense. X to the 4 turns into x to the 3. Let's have a look at this half circle function. Looks a little bit different. So we do have a zero gradient here. It's right in the center. Let's drop that down. And let's look at this weird stuff that's happening on the very edges. What is the gradient at x equals -2? Well, it's the side of a circle. It's going to be undefined. It's just a vertical line. So we're actually going to have asymptotes at x equals -2 and x equals 2. And it's over here, we've got a positive gradient. And here, this has a gradient of 0, so down there. And then over here, we have a negative gradient, but it goes into the far negative. So it's sort of going to look like a tan graph there. Here's another one. Let's start with the zero gradients. We do have to consider maybe the steepest points. So I'd probably say this point here looks like the steepest, and this point here looks like the steepest, although it's negative. So this is the steepest positive. So perhaps we'll put it up there, and this is the steepest negative. Perhaps we'll put that down there. And over here, we're going to be flattening out. So going towards a zero gradient. And we just join the dots. This one should go, and we've got an asymptote there. And lastly, we'll do this funny looking one. Now I'm going to adjust this just a little bit. I'm going to pretend that that has asymptotic behaviour there, and that's indicated by the dotted lines. So do we have zero gradients? Well, not really, but almost, and that's at the edges here. So this asymptotic behaviour means we're going to have an asymptote at 0. It's positive there, so it'll be like that and like that. And I would say this point here has a maximum gradient. So you've got your steepest point there. Let's just pop that there. Oh, not the best curve, but you get the idea. All these examples, we first plotted where our zero gradients were. We looked at whether it was positive or negative gradients either side of that. And in some cases, we had to consider asymptotic behaviour or where the steepest gradient was.